Hello everyone, welcome back to the channel Frontline News. Today we're diving into 5 cutting-edge U.S. Navy weapons and systems that are shaping how the United States projects power at sea and why they matter in keeping strategic competitors, especially China, at bay. First up, Hypersonic Strike. Imagine a weapon that travels faster than 5 times the speed of sound, maneuvers unpredictably, and reaches targets far beyond the horizon before defenses can react. That's exactly what the Navy's conventional prompt strike program is trying to deliver. Ship and submarine launched hypersonic weapons that give the fleet a prompt, conventional way to hit time-sensitive or hardened targets anywhere in a theater. Hypersonics change the math of deterrence. Instead of waiting for a target to move into range or for carriers to sortie closer, a single vessel or sub can hold critical land and sea targets at risk in minutes. That compresses an adversary's decision timeline and raises the stakes for any aggressive move. There are technical hurdles: heat, guidance under extreme speed, and survivability through re-entry. Like conditions but tests in 2024-2025 have pushed the Navy and its primes to the point where fielding is now a near-term conversation rather than pure science fiction. The result, a credible, hard-to-intercept offensive capability that complicates Chinese planning. The second big category is directed energy, high-energy lasers and dazzlers that can burn, blind, or confuse incoming threats almost at the speed of light. These systems aren't meant to replace missiles. They're designed to defeat swarms of drones, small boats, and some classes of anti-ship missiles at very low per-shot cost. The Navy's Helios high-energy laser and integrated optical dazzler and surveillance program and other shipboard laser initiatives have reached milestones where they've engaged airborne targets and provided real operational data for the fleet. That's critical. Lasers offer a magazine that only needs power, not a resupply of costly interceptors, which is a big advantage in a protracted fight far from port. Lasers have limits, range, atmospheric effects, and the sheer power required to disable heavy missiles. But for the modern environment where adversaries use inexpensive drones and guided rockets en masse, a reliable turreted laser turns those costly salvos into survivable nuisance fire. For ships guarding a carrier strike group or key choke points, this defensive layer matters a lot. Third, long-range anti-ship and precision strike missiles like LRASM and upgraded Tomahawks extend U.S. reach and complicate China's ability to mass influence the seas. LRASM's stealthy sensors and autonomy let it find and prosecute ships in contested, noisy electromagnetic environments, which is exactly where modern navies would try to hide. Lockheed and partners have continued integration and sensor upgrades to keep LRASM relevant and harder to spoof. From the Chinese perspective, a dispersed U.S. force able to launch autonomous long-range strikes from aircraft, ships, and submarines forces them to assume they could be targeted at any time. That disperses their fleet and complicates the defended area they must cover with escorts and layered air defense, which is expensive and resource-intensive. Fourth on the list is the invisible backbone, the attack submarine force, especially the Virginia class with the new Virginia payload module. These nuclear boats are stealthy, survivable, and flexible platforms that can carry massive strike payloads, Tomahawks today, and hypersonic conventional weapons tomorrow. Adding the VPM dramatically increases undersea strike capacity without exposing the platform on the surface. Submarines are deterrents because they are hard to find. If a potential adversary cannot be confident they can locate and neutralize U.S. submarines before a conflict, the risk calculus of trying to seize advantage changes. A submarine able to launch deep strikes at long range from under the sea and at great distance complicates offensive operations across the Western Pacific. Our fifth category is unmanned systems across the surface and air domains: carrier, Land-based unmanned tankers like the MQ-25 Stingray, sea-based unmanned surface vessels, and the emerging family of medium and large USV that operate with human-supervised autonomy. These platforms expand the reach, endurance, and sensor footprint of the fleet without putting sailors directly in harm's way. The MQ-25 extends the carrier air wing's range by refueling manned fighters at sea, which lets carriers project air power from farther away and reduces their vulnerability. Meanwhile, Ghost Fleet USV and related programs give commanders attritable platforms to scout, shape the electromagnetic picture, and even serve as sensor missile nodes when needed. Now let's unpack each of these 5 systems in more detail: what they are, how they work in the real literal, and why they matter. Conventional prompt strike, the Navy's hypersonic answer, is not just about speed. It's about changing the geometry of a strike. On a carrier strike group or a forward deployed destroyer, CPS missiles promise the ability to put precision conventional effects on a wide range of targets, from missile launchers to hardened command bunkers, much faster than current cruise missiles. That speed and unpredictability undermines the concept of sanctuary behind long-range anti-access/area denial bubbles. Hypersonic weapons also allow the U.S. to threaten high-value targets deep inland from sea platforms, which in turn forces an opponent to hold more assets back in reserve or to disperse them widely. That dilution of forces is a strategic effect in itself. If an adversary cannot mass forces for an offensive because each mass becomes vulnerable to prompt strikes, their freedom to act is constrained. Operationally, the Navy is pairing hypersonic delivery with specialized platforms. The stealthy Zumwalt-class destroyers are being adapted to carry hypersonic missiles in retrofit packages, while the Virginia-class Block V submarines with the VPM are being eyed as undersea hypersonic launchers. These adaptations aim to balance survivability, stealth, and punch, but hypersonics are expensive to develop and field, and their operational employment requires new doctrine. The Navy has been working on tactics, target nomination processes, and defensive measures to reassure allies and avoid escalation ladders that could accidentally lead to wider conflict. The strategic payoff is notable. A credible hypersonic capability raises the cost of aggression by creating fast, hard-to-intercept options for punishment or denial. Directed energy weapons, lasers, dazzlers, and microwaves are the next layer of modern naval defense. The Navy's Helios program and earlier prototypes like Odin show that solid-state lasers can be integrated into ship combat systems and successfully engage smaller aerial threats. The appeal is economic and tactical. 1 kilowatt-hour in the ship's generators can replace entire missiles when the target is a drone or incoming mortar round. Lasers operate at the speed of light, which changes reaction windows for soft targets and reduces the need to carry enormous inventories of interceptors. That's crucial in a protracted fight where resupply lines are stretched. The Navy's investment in laser tech, including tests in a variety of climates and conditions, reflects a recognition that layered defense increasingly requires non-kinetic, reusable effects. Still, we need to be realistic. High-energy lasers currently struggle against fast, maneuvering ballistic threats or highly armored missiles. They also require coolers, power management, and robust beam directors. So the Navy is integrating lasers as part of a layered system. Kinetic interceptors at long range, directed energy for short-range swarms, and electronic warfare to confuse and degrade adversary targeting. Long-range anti-ship strike LRASM and upgraded Tomahawks is where offense meets stealthy autonomy. LRASM brings low observability, multi-sensor seekers, and onboard mission management that helps it find ships attempting to hide in cluttered littoral environments. Integrating LRASM onto aircraft like the F-35 increases the aircraft's punch and lets strike packages engage maritime targets from stand-off ranges. That integration work has shown demonstrable progress in 2025. From carrier-borne strike jets to stand-off bombers and submarines, the dispersion of long-range strike means the U.S. can attack sea forces, choke points, and logistics nodes without putting the carrier at immediate risk. It also creates a dilemma for China. To counter pervasive long-range anti-ship threats, they need more escorts, more sensors, and more cost-intensive defenses across a wider area. LRASM is more than a missile, it's part of a sensor distributor network mindset. When connected to ISR platforms, data links, and AI-enabled targeting, these missiles can be queued and updated in flight, making them resilient against attempts to decoy or jam them. Submarines remain the quiet ace. Virginia-class upgrades, particularly the Virginia Payload Module, turn these attack boats into multi-mission powerhouses. The VPM brings space for additional vertical launch tubes, and that increases the number of Tomahawks, special payloads, and in the near future, conventional hypersonic missiles that these boats can carry. That boosts undersea strike density without adding more surface ships to combat a heavily defended theater. Submarines are inherently survivable because they operate below the radar literally. An adversary who cannot be sure where U.S. submarines are positioned must plan for the possibility of undersea strikes. That uncertainty preserves U.S. operational options and imposes constraints on any power attempting to push into contested waters. Beyond strike, submarines contribute unique intelligence and sea denial capabilities, covertly mapping seabed sensors, hunting enemy subs, and inserting special forces. Put simply, undersea power is durable and difficult to negate. Unmanned systems, the MQ-25, medium USV, and larger LUSVs change the economics of naval operations. The MQ-25 extends fighter range by providing at-sea refueling for jets that otherwise would have to operate closer to hostile shores or carriers. That distance buys survivability for the carrier itself while extending the reach of the entire air wing. On the surface, Ghost Fleet Overlord prototypes and the Navy's rolling push for a family of unmanned vessels create opportunities to put sensors and weapons into forward areas without risking large crews. USV can act as scouts, relay nodes, and when doctrine permits, attritable missile platforms that complicate enemy targeting calculations. The operational effect of unmanned systems is a more distributed, resilient fleet. Instead of concentrating power on small numbers of high-value ships, commanders can layer robotic platforms around task forces to soak up enemy sensors, draw fire, or perform repetitive and dangerous missions. Let's pause on integration and command challenges. High-end weapons are only as good as the networks and doctrine that tie them together. The Navy's investments in data links, cooperative engagement capabilities, and AI-assisted battle management aim to make missiles, lasers, drones, and submarines more than the sum of their parts. When an ISR plane, an unmanned surface vessel, a submarine, and a destroyer all share a common tactical picture, a single decision can produce synchronized effects across multiple domains. This networking creates dilemmas for adversaries. They have to hide not just from one sensor, but from a web of sensors that can queue long-range weapons and direct layered defenses. That's central to modern sea control strategies and why these 5 capabilities matter together. There are also important logistical and industrial realities. Hypersonics need factories, precision components, and supply chains. Lasers depend on mature power and cooling systems. Missiles require sustainment and training pipelines. The U.S. Defense Industrial Base has been scaling up, with major contracts and sustained investment aimed at moving prototypes into deployable inventories. That flow from lab to fleet is a key barometer of when these systems truly reshape strategy. Deterrence works when the cost of aggression is clear, credible, and perceived as imminent. Hypersonics give a rapid, credible punishment option. LRASM and long-range strike make maritime concentration risky. Lasers reduce the attrition risk from mass low-cost attacks. Submarines provide hidden punch, and unmanned systems extend sensing and extend effect at low cost. Together, these five elements compress and complicate an adversary's options. Critics caution about escalation dynamics. Weapons that strike quickly or look like first-use strategic systems can raise the risk of miscalculation. The Navy is aware of this and has been working on doctrines, Allied consultation, and command and control safeguards to ensure that the operational employment of these systems supports deterrence without inadvertent escalation. We should also recognize countermeasures. Adversaries invest in electronic warfare, decoys, sea denial, and anti-access networks to blunt these capabilities. That's why adaptability matters. The U.S. focus is less on a single silver bullet and more on a resilient, layered approach that mixes kinetic and non-kinetic tools, humans and machines, and surface and subsurface options. What does this mean for allies and partners in the region? These systems not only strengthen U.S. defense but also enhance Allied deterrence when shared or integrated into joint operations. Partner navies can benefit from U.S. sensor data, resupply concepts, or even interoperable strike options which collectively raise the cost of coercion across multilateral lines. Now, a realistic look at timelines. Some capabilities like LRASM integration and the MQ-25 are already in the fleet or rapidly scaling. Directed Energy has successful prototypes and limited operational deployments. Hypersonics are moving from test to initial fielding, with ongoing work to put them on specific ship and submarine classes in the late 2020s. Virginia-class submarines with VPM are being procured and will become the principal undersea strike carriers for these new munitions. The industrial momentum and fielding plans are clear signs these are not hypothetical toys, but real tools being woven into naval planning. For the viewer wondering what this looks like in practice, picture a carrier strike group whose air wing is refueled by MQ-25s, screened by escorts equipped with lasers for drone defense, and supported by distant Virginia-class submarines that can launch hypersonic volleys if necessary. Add in USV patrolling forward lanes and LRASMs on aircraft to deny surface concentrations. That distributed, layered force is designed to hold sea lines of communication open and to deny an adversary decisive control of contested areas. Finally, let's be candid about limits and risks. Research, testing, doctrine development, and sustained budgets are required to keep these systems effective. Adversaries will adapt, and no technology is a panacea. But layered capabilities that combine speed, stealth, endurance, and affordability create a robust deterrent posture that raises the cost of aggression and buys time for allies, diplomacy, and broader responses. If you're building a long-term perspective on maritime security, watch these elements closely: hypersonic fielding and where they're stationed, the pace of laser and directed energy deployments, how widely LRASM and similar missiles are fielded across platforms, the rollout and mission sets for Virginia-class Block V subs, and the operational doctrines for unmanned fleets. Those 5 areas will tell you a lot about how the U.S. Navy intends to shape maritime competition in the Pacific. To wrap up, hypersonics, directed energy, long-range anti-ship strike, Advanced submarines and unmanned systems form a complementary set of tools. Each addresses a different vulnerability or strategic requirement, and together they form a practical approach to deterring or defeating high-end maritime coercion for anyone tracking China, U.S. maritime competition. These capabilities are central to the next decade of naval planning. Thanks for sticking with this deep dive. If you found the breakdown useful, hit like, subscribe, and let me know in the comments which of these 5 systems you think will have the biggest long-term impact, or which one you want me to explore in a standalone video. Stay curious, stay informed, and I'll see you in the next one.